only 2 more chapters. Well, it's kind of, we're doing 2 chapters next week, but it's like 3 sections. So 2 more weeks of new stuff, and then we are done. 1 last unit exam after that. Let me pull up, it's been a while since we've talked about the schedule. So let me pull up the schedule update. Let's see here. So schedule update, I know I put it in here somewhere. There we go. So we are in chapter 11 right now. We got 2 sample inference. This is where it actually gets interesting. We can start comparing 2 groups. And so we're going to do some examples today with that. And so that's chapter 11 this week. Chapter 12 and 13, really 3 more tests. Each section has another test we're going to learn how to do. And then we're done with new content. And then our last week, we'll meet on Monday to do exam review. And then Tuesday, I'll release the exam 3, actually exam 4. So exam 4 will be released in the morning. And then it'll be due Wednesday, kind of Wednesday at the end of class kind of thing. That'll be the plan for that. The semester does end on Wednesday anyway. Oh, and this is not true anymore. That all changed on me. Okay, so does anyone have any questions just about the plan for our last couple weeks here? About what's due or anything like that? Any scheduling questions? All right, I'm not seeing any. Let me know if you do have any. Today, I put a post, just kind of updated it a few seconds ago. I did update grades. There were a couple things that I hadn't entered that were done like the week before we left campus, so I updated those. I also updated the participation and homework categories and just checked them to drop your 2 lowest scores just to kind of give you a buffer. There's been kind of some crazy stuff here, so that way if you had kind of a bad homework score on a couple sections or something, that won't be the end of the world. I do have some chapter 11 extra practice that I just uploaded, and we can do that if there are no questions. And then then I asked you too, if you could, I'm kind of interested to see, so we can talk about this on Wednesday. I made a little form, kind of let me know what you're most excited to do once our shelter in place is lifted. Okay, so maybe let's start with the homework, or I have the practice here, which is for your quiz this Friday. Did anyone have any questions from the practice that you wanted to ask about? Mm-hmm. All right. So with this one, we're going to do, we're going to try to compare proportions. The 2 ways we can do the comparing 2 proportions is if we have the data, we could use the data. It would be kind of hard on this one, or we could just get the counts. If we get the counts for the 2 groups. So what we're going to try to do is we're going to try to see if there's a different thoughts about body image and if there's a difference by gender. That's a common one. We're going to look to see if there's a difference by the race ethnicity category. So we're going to do a contingency table of thoughts on body by race or ethnicity. So let me go in to our group data list. I feel like it's on the last page. Oh, second to last page. So health behaviors. It's under the statistics, I believe, menu, and then there's a table. I can zoom in a little bit. No, it's not letting me zoom. There we go. Stat, tables, and then contingency is what we want. And then we do have data. So I'm in the health behaviors in school-age children, stat, tables, contingency with data. And then we wanted to do, and it doesn't matter which one's row, which one's column. We're just going to try to get the counts. So we wanted to do, we'll say race or ethnicity for rows, and then it was thoughts on body for columns. And I'm just going to hit compute. And what this will give us, it's a big table, but what it gives us is the counts for all these different categories for each race or ethnicity. And then the first question, we're going to focus on those who see themselves as about the right size, and we're going to look at the totals for Black or African American children and then Hispanic Latinx children. So if we go over here, we have Black or African American about the right size. So you just want to write this down. 135, I'm going to make a note for myself here. So Black or African American is 1, 3, 4, 5 out of 2,136 total Black or African American children. And then the Hispanic Latinx is close. Oh, it's really close. 1,366 out of 2,354. So it's pretty close. We could just kind of ballpark compare those. What if we just divide those? 1,345 divided by 2,136. So that's about 63%. And then, excuse me, 1,366 divided by 2,354, that's 58%. So 63% for Black or African Americans see themselves as about the right size, and then 58% for Hispanic or Latinx. It was a similar, you can see it's like a similar number agree, like made that statement, but the denominator is bigger. The Hispanic, there are simply more Hispanic or Latinx students. So we're going to need those counts. All right, then we're going to check to see if the conditions are met. Are the populations independent of each other? I'll let you check all of those. They should all be met for this particular case. It's a random sample, so the populations are independent of each other. They are pretty big sample sizes, so number 2, those conditions will be met. And then are both sample sizes less than 5% of the population? Keep in mind the population is all children, right? It's all children in the schools. It's a huge sample or a huge population size. So this is definitely less than that. So let's perform the test. And so the test, now that we have the counts, we will be able to do the test. And it's in proportion stats, but now we're just doing 2 samples because we're comparing 2 populations. So 2 sample, we don't have data. It always feels like we do, but when you have counts, you just have summary. So with summary. And then number of successes, we'll do population 1 as the Black or African American, 1,345 over 2,136. And then sample 2 is the Hispanic Latinx, 1,366 over 2,354. Oh, 54. I don't know what to test. Is the proportion of Black children who view their body as about the right size statistically higher than? Ooh, okay, so we need to be careful. Let me do a little, I'm just gonna do something here. So little note here. So proportion 1 is the proportion of Black or African American students, and then proportion 2 will be the proportion of Hispanic Latinx students. And so I'm wondering about the test is, the null hypothesis is P1 greater than P2, right? That was the null hypothesis is that they're equal, I'm sorry, P2. And then the alternative, HA or H1, is that P1 is greater than P2. That's what we were asked, right? Is the proportion of Black children who view their body as about the right size statistically higher than that for Hispanic Latinx children? Okay, so the reason why I wanted to mention this is StatCrunch phrases it differently. StatCrunch has P1 minus P2 equals 0. That's what they have, which is the same. If you look at it, if P1 is equal to P2, then the difference is 0. But we need to make sure we get this inequality the right way. So P1 minus P2 is their alternative claim. Going back over here, you can see P1 minus P2. So the question is, do we want not equal to, less than, greater than there? And we think P1 is bigger than P2. So can you tell which one we want if we think P1 is bigger than P2? Can go back here. Anybody know? You can just type a greater than, a less than, or a, like an equal with a slash or something in the chat. We need a not sure option. So again, you can just, it's a good guess, right, Brittany? Like, well, I don't know. It seems like this is greater than, so it's got to be one or the other. So you can even just solve it algebraically. If P1 is greater than P2, you can subtract P2 from both sides, and you get P1 minus P2 is greater than 0. So it's actually greater than. The key is, as long as you keep the order the same, the inequality will be the same. And for me, I just think of, well, if P1 is bigger than P2, well, then P1 minus P2 will be a positive number because the first number is bigger. P1 is bigger than P2, so it should be greater than 0. And so that is our test. We're going to do a greater than. We think that P1 minus P2 is greater than 0. On the test, your last unit test, I'm going to ask you for this. Either one of these is okay, but you do need to put the correct one there. You will need to type it out or write it out. We're typing it, right? Typing everything. So you will need to enter that. I'm going to ask you what the null and alternative hypotheses are there. So you do need to enter that. One thing that's really important in chapter 11, since you have two proportions, you have to define which one is which. So you'll note I did that here, and that's also required. I can't know if P1 is bigger than P2 unless you tell me what P1 and P2 are. So then it's easy from there. Then we just hit compute. We get our results. We get our p-value. It's very small, so we would reject the null hypothesis. What is our test statistic? This is step 1, right? Step 1, null and alternative. Whoops. Step 2, and we'll say alpha. We'll do our usual 0.05. 3, it should be a z statistic. 3.38. And then the p-value was about 0.0004. And then what do we have? Then we would reject the null hypothesis and say there is enough evidence to support the claim that the proportion of Black or African American children, this is going to be a long phrase here, long sentence, who see their body shape as about the right size is higher than the proportion of Hispanic Latinx students or children. All right, so again, that wording there is always, is there enough evidence or not? And then you're writing out your claim in words. The proportion of Black or African American children who see their body shape as about the right size is higher than the proportion of Hispanic Latinx children. So we ended up doing the whole thing there, Rachel. I know your question was primarily about the table at the beginning. That's correct, yes, because all we care about here is we want to be able to do the test, and the thing we need to do the test is we need those counts. So it's not one of those relative frequency things, which were like really confusing from chapter 4. So here we're just going to do the counts and then use those counts to do the test. Yeah. All right. Any other questions on that one while we're in there? That I'm trying to get to that practice that we did all of question 1 here. Are there any other questions from, if we didn't do all of question 1, we did A through D. There's more to it here. We just did A through D. Any other questions on that hypothesis test comparing the two proportions? All right. Are there any other requests, any other questions that you wanted to ask? Ooh, Brittany, that is a really good question. Brittany asked, does it matter which one is P1 or P2? And the definite answer here is no, it does not. That's why, though, it's really, really, really important to label them. So we could redo this whole thing. I'll even show it to you just quickly here. We could redo the whole thing. We could do the null hypothesis is that P1 equals P2. Oops. So we're redoing the whole thing here. And by redoing, I mean, I'm gonna say P1 is the proportion of Hispanic Latinx students. So I'm gonna do the reverse. And then P2 is the proportion of Black or African American students. So the null hypothesis is still that they're equal. And now the alternative this time would be that P1 minus P2 is less than 0 because we think that Black or African American is a larger proportion. So we think P1 minus P2 will be negative, right? And then all the steps 2, they're all gonna be the same, but 3, so in the test itself, watch what happens here. Stat, proportion stats, to sample with summary. And I'm glad I wrote down my counts. So now we're doing Hispanic Latinx as proportion 1 or sample 1. 1366, 2354, and then 1345, 2136. So I just switched them now. Now I've got the Hispanic Latinx as sample 1, and then the Black or African American as sample 2. And now I think it is less than, because I think the Hispanic Latinx proportion is less than the Black or African American proportion. And when I hit compute, you'll see some familiar numbers here. Look at that. Now the Z is negative because we changed the order. Now we made it negative, but the p-value is the same. That is not coincidence. That should be the same. In fact, I knew that was going to be the same. Like you could hear me talking about it. Like I knew that was going to be the same because all it did was change the order, and which changes the sign, but it doesn't change your conclusion. You still reject the null. And so yes, you do think that the proportion for Hispanic Latinx is less than the proportion for Black or African American, or the proportion for Black or African American is more than the proportion for Hispanic Latinx. So it really doesn't matter. And if you're nervous about how do I know which one to do first, I would just recommend just pick one. Just pick which one is going to be population 1, but then write it down and then label which one is which, because that will change your alternative hypothesis. Yeah, if you did this in reverse, you'd get 0.9996 and you'd be super confused. You're like, wait a minute, p-values of almost 1, that doesn't make any sense. That's usually a sign that you did it in the wrong direction. Yeah, so you just got to be really careful. And that's true, actually, Brittany, that's true for this whole chapter. Chapter 11. It doesn't matter which one you pick for population 1, whether it's a proportion or a mean or a variance, but you just need to be specific and label it because it will change your alternative hypothesis. Yeah, it's a really good question to bring up. It's so funny, I was getting some tips. My wife and I were talking about, she does doing lots of conferencing now too. We're getting tips, and it's so funny. I always like to look at students and like, you know, make sure that they know that I'm looking at them. So I have to like look at the camera, and that's how I look at you. So I'm looking at the camera. It's just, I don't know, it still sucks. I'm just trying to make it through. But hey, that's what we got to do. All right, that was a really good question, Brittany. Rachel, I think we answered your question. Any additional questions from the practice while we're in there? All right. Oh, there we got another one for the mean. Will H. Yes. So Brittany, I don't know if everyone can see this. Brittany's question: for the mean and proportion problems, will the null hypothesis almost always be equal to 0? Yes, because usually what you're doing is you're assuming the null hypothesis is that the two populations are the same. And so if they're the same, then the difference in the proportions or the difference in the means would be 0. I like how you mentioned for mean and proportion problems, because it's different for variance. For variance, you do a division, you divide them. So if they're the same, what would be the null hypothesis if you divide them? What do you think the division would be? Right, Brittany, it'd be 1. Yes. So let me write those here on our little scrap paper that I had here. So for comparing two proportions, your null hypothesis is almost always P1 minus P2 equals 0. You know, in theory, you could test, hey, is this proportion like more than 20% higher? Then your null hypothesis is that it's 20% higher, equals 0.2. And then your alternative is that it's greater than 20%. So in theory, you could do that. In practice, you like 99.9% of the time, you're looking for equality. For comparing two means, your null hypothesis would be that, I need to use the equation editor here, mu1 sub 1 minus mu, isn't that weird how I make that like notation there, equals 0. And then for comparing two, and it's whether it's standard deviation or variance, it's the same thing. The test is about the variance. Oops. Well, I haven't. There we go. Sorry. And it's sigma 1 squared, the first variance. I guess you could do sigma 1 over sigma 2 squared equals 1. That's your null hypothesis, is that they're equal. And the reason why it's not a subtraction, it's hard, it's just kind of beyond us. It has to do with the calculus behind it and these statistics, kind of why you do a division for variance. I don't have a great answer for that for you. I don't think I really learned that until I took like graduate level statistics courses about why that was all true. And I don't even know if I could prove it again right now. So it's not worth it for you to worry or stress about, but it is important to note. And so you're gonna wanna start a formula sheet and kind of writing down some key things. And so this was a good point that Brittany made about, hey, I should write that down and have those so I know what my null hypothesis looks like for each of those tests. It can be easy to get dependent on StatCrunch because it has that. It has it all in there. But if you don't know what you're doing, you can get in the wrong menu. And then, do you see the ratio here? You can get in the wrong menu and you're doing the wrong test and it's giving you some results, but that don't make any sense, but you don't understand it anyway, and you just write them down, even though they make no sense. So it's really good to kind of keep your thoughts very organized and know exactly what the null and alternative hypothesis need to be. This is all pretty much we're going to do. There's a couple of confidence intervals here, but this all just the focus of this week and next week is a bunch of hypothesis tests. And so you're going to get to the last unit, and it's going to be chapter 10, 11, 12, and 13, which is like 2 or 3 confidence intervals, and then 10 different hypothesis tests maybe. And so it's super, super, super important to know which test you're doing and know what the null and alternative hypotheses are for that test. Yeah, and we're getting to like, this is like the whole point of the course right here is this unit. So it's super important to be organized, know which test you're doing, know why you're doing it. By the way, like the last test, I was like, just impressed. We did 2 of the 3 weeks were remote. We just had 1 week together and then the rest was remote, and like people did really good. I mean, not everybody got an A, but like it was some good work. So I'm hopeful that we'll continue that through and finish strong here. All right, good questions. Any additional practice questions? Like warming up. I think the rain is coming, but it's like warm in here right now. All right. can someone remind me, did we talk about, I feel like we did more than once. We talk about the grading change for grades at the end of the semester, like the credit, no credit, and all that. I feel like we did, but all of my classes are blending together. Yes, no? I'd be happy to do it again. Like no one's answering anything. That tells me like we didn't talk about it. Let me pull up. Let me pull it up again. I'll remind you. Sign in here. I think because I know I saved the email. I always save all my emails, but I know I marked that one in my inbox here. Let's see. Yeah, it was a while ago. So long ago, I can't find it. Oh. I thought I marked it. There we go. Yep, it's marked. This one talked about extension for the last day to withdraw, goes all the way until the Wednesday of finals week, like the last day of the semester. And then the no harm grading, where you can check credit or no credit. Do you want to just, if somebody, like if you want to go under, I think on the bottom, does it show on the bottom of your screen a yes, no? Or do you have to like check on participants or something? Does anyone want me to go over that again and kind of talk about that? Okay, so I'm going to take a couple minutes here just to remind you about how this is going to work. And this is true for all of your classes, not just this class. So first of all, number one, I think everybody's going to be okay. But maybe for your other classes, if you want to withdraw, you can actually do that all the way up until May 13th, which is, it never happens. Like you can't decide like, oh, I turned in my final. I decide I want to withdraw. This is not usual times. So you can do that all the way through Wednesday. But once the semester has done, then you can't anymore. But there are options after that. And this is true for all of your classes. There's a no harm grading policy. So what this means is it has nothing to do with me. I'm just going to turn in my grades, A, B, C, D, F. Everybody's going to get a grade now. It's too late to withdraw from me. So I'm just going to give everybody an A, B, C, D, or F. But after the semester is done, you can decide, you know what? I got a C in this. That's not really fair that I'm going to get this 2.0 GPA weighting on my GPA. It's going to pull my GPA down, and all I need is the credit for graduation. You can actually choose then after the semester to just call it credit. Now that doesn't, you want to be really careful if you do that for classes that have like a course above them, like Calc 1. I'm telling my Calc 1 students, you need to be very careful because most of you are taking this so you can take physics or so you can take Calc 2. And if you get a credit and you transfer to the U of I, they might not take it then because they say, no, you have to have an A, B, or C in Calc 1. But for stats, most people, it's like part of a graduation requirement. Some students even take the AP stats class in high school and then get credit for this, and then they're done. They have that stats credit done. They don't have an A, B, or C, they just have credit. So you can choose that after the semester. And similarly, if you get a D, you can choose a no credit. You can say, you know what? I don't want the penalty of that. I'm just going to choose no credit, and then it just won't get counted in your GPA. So the credit, no credit, don't count in your GPA at all. The credit counts for graduation, counts to the 4 credits will count towards graduation, but it doesn't affect you. And then there are no Fs. Anything I enter in as an F or any other instructor turns in an F, they'll automatically get converted to no credit. So it's like a no harm grading penalty. So nobody should be harmed by a grade. So you have until June 4th. They want to make sure that you talk to an advisor before you do that. So I don't think you can go on the system and click anything. You have to actually talk and ask someone, hey, I want to change this class to a credit or whatever, whatever it is. You have to talk to an advisor. It says that in here somewhere. Students will be required to speak with an academic advisor if you're going to convert to a credit or a no credit. So yeah, that's like really valuable, I think, for some students. You know, even if you were getting a C before and maybe you were already going to get a C, then you get kind of a bonus like, hey, nice, I can still get my credit and I don't have to have the C on my GPA. Bonus, like maybe there's something good to come of it. For, you know, if you're getting an A or B, then I would just say, you know, keep going for it. But it's up to you. Certainly if you get an A, keep the A, because that'll help your GPA. If you have a B and like you want to keep your 4.0, like, I don't know, doesn't matter to me. That's fine. So I don't know, is that, anybody have any questions about that? All right, feel free, shoot me an email if you need any clarification on that. If I know the answer, I'll help you. If I don't know the answer, I know people who know answers, so I can get that for you. All right, so let's do next. Let's go and do a little practice. We'll have time for maybe one or two of these questions. I just made 3 more examples from chapter 11. So there's this chapter 11 extra practice down here on the bottom. I think let's not use the data yet. Let's just do, I think the first example uses, it's actually some new data. I hope you don't mind me using some coronavirus data. This one we should be able to do here. So I'm just going to open up that extra practice document here. I have it in Word format here. I think that's what I posted to in case you want to edit it. So I don't know if anybody was keeping up on the national news. Maybe you're not paying attention to that for whatever reason. That's fine. One drug that was recommended as a possible cure or maybe to relieve some symptoms was this hydroxychloroquine. I don't know if that's pronouncing it right. And then they thought maybe you could use that combined with azithromycin, which is like Z-Pak, an antibiotic, which seems weird, like the antibiotic would help because this is a virus. But some people thought that would work. And so there have been tests that have been done. There are a few of them that have been done. And one that was published is this from the VA, the Veterans Health Administration. They investigated this. They did a test on some veterans. I don't know how that makes me feel, but anyway, that's who it was on. So I'm going to open this up. Okay. And there's some language in here that you won't understand, but you'll actually get most of it. So here's the researchers. That's where their background is. And here's the abstract. The background here. The U.S. Food and Drug Administration authorized the emergency use of this drug of clinical trials. Now, a lot of times you have to go through a huge approval process to even try a drug. So here they did this emergency approval to let people try it. And what they did is they had some patients who were given there's three different things. They either had this HC, this hydroxychloroquine alone, or they had it combined with the azithromycin, or they just had, they were just on a ventilator and they didn't have any medication. So there's 3 groups here. So we don't really have a lot of statistical tools for 3 groups. We do have a way to compare 2 groups though. Okay, so we have some results here. We have 368 patients were evaluated. So the HC, there were 97 of those. HC plus AZ, there were 113. And then the no HC, there were 158. And then they have these death rates for each of the groups. So these are not huge numbers. So this has got to be like 25 out of 97 or 26 out of 97. We can figure that out. That was the death rate for the ones with the hydroxychloroquine. Then with the azithromycin, it was 22.1%. And then with neither of those, it was only 11.4% for these particular groups here. Now, those death rates are really high, but this is not taken from a random sample of people with the virus. This is from people who are already severely sick and on ventilators. So keep that in mind. It's not killing that many people. So these were already severely in need of assistance. So they were pretty significant. So what we're going to do here, we could look at how many needed the ventilator. That's the second percentages. We're gonna look at the death rates and compare the death rates. Now, clearly, if you look at the rates of death, the medicines did not help. In fact, it looks like they made it worse. So what we're going to do is we're going to look at, did they make it statistically worse? Okay, so the 27.8% is obviously more than 11.4%, but it's relatively small samples. So is it statistically worse? Same thing, 22.1%. Is that statistically worse than 11.4%? So let's mark these down. I'm gonna, maybe I can just, I'm just gonna cheat here and just do a little snip of that right there. And then I'm gonna go over to my Word document here. So is there evidence, first of all, first question here, is there evidence that hydroxychloroquine or a combination of that with azithromycin improved, do they improve outcomes? Absolutely not. Absolutely not. Okay, I just did my little paste there to hold that for future reference. So they definitely didn't improve outcomes. So the question is, are they statistically worse? So to Brittany's point, we need to pick some population. So I'm going to pick population 1. Was it statistically worse than doing nothing? So let's, I guess maybe we could combine the two groups. Maybe, yeah, let's do population 1, any use of hydroxychloroquine. And then population 2 will be the no hydroxychloroquine. And let's make some notes. Oh, we're gonna have to do some math here, some arithmetic. So 97 plus 113. Oh, sorry, you need a calculator. 97 plus 113. So 210 total patients. And then we need to do 27.8% of 97 plus 22.1% of 113 to get the total number of deaths for that group. Okay, 0.278 times 97 plus 0.221 times 113. So it looks like about 50, looks like 52. That is really high. That's not good. No hydroxychloroquine was 158 patients, and then 11.4% of that, 0.114 times 158, 18 deaths. Okay. Let's see here. We don't know a lot about the patients. Remember, they're supposed to be independent. I think we can assume that there's independence here. We would have to read this research article a little bit more to figure out, and it's a long, like that was just this summary here. This is like an abstract summary, like a one-page summary. The whole article is some, I don't know, however many pages. Right? There's a lot of information there about where the patients came from, and we're not going to be able to understand or read all that. So we're just going to assume that they are independent. And I think the conditions are met. If not, we're going to practice as if they were. But do I have those conditions up still? They're in the practice document. We definitely have less than 5% of all COVID-19 patients, so we're good there. So I'm going to check this N1 times P1 times 1 minus P1. I think we should be good on both of these this time. Let's see. So N1 is the conditions. N1 is 210 times the P1 was, I guess it's going to be 52 out of 210, whatever that is, times 1 minus 52 out of 210. Well, let's see if that one is met. 210 times 52 out of 210 times 1 minus 52 out of 210. Yeah, that's 39. Unless I made a typo here, you can double check me. So that's good. It's greater than 10. And then the second one is 158. This one I'm a little more nervous about, because the 18 is small. 18 out of 158 times 1 minus 18 out of 158. Let's see, 158 times 18 out of 158 times 1 minus 18 out of 158. Whew, okay, we're good. 16. Yes, so we can do our test. Excellent. Okay, so all this so far is to see, can we even compare the two populations? So we have less than 5% of all COVID-19 patients. That's definitely true. There are like 200,000 in the US, something like that. We're going to assume that they're all independent. Now, they might not be, like there might be a husband-wife. Do you know what I mean? Or there might be like siblings who both got it because they hung out together, and the siblings have similar genetics, and so they would have similar results. They're not independent. So, yeah, but usually for purposes of like this, it's reasonable to assume that the people came from different areas, so they're all independent of each other, but we can't know that for sure. So let's do the test. Okay, so step one, the null hypothesis is that the proportion who die, who use the hydroxychloroquine is, I feel like I'm either getting better at saying that, or I think I'm getting better at saying it and I'm just saying it faster. The null hypothesis is that they're equal. And then the alternative, let's see, we were wondering, is it worse? So basically, is the death rate higher, statistically higher, using hydroxychloroquine? Is that greater than? We don't have any alpha that's given to us. So we'll use our friend 0.05. Okay, I think we're ready to jump into StatCrunch. I want to pause. I feel like I've been going really fast. By the way, there is a button. I don't know if you see this. I don't know if you can see here. That's too small. But there's this little go slower button that you can click. I think you have to, it might be along the bottom, or you might have to click like participants to see it. So you can tell me to go slower if you need to. So are there any questions about all this information I have right now? All right. So it looks like we're okay. All right, so let's move on. Just interrupt me at any point if you have any questions. I think we're ready. This will be similar to the practice that we did, that one that Rachel asked about earlier. We're going to go into StatCrunch, any StatCrunch, it doesn't matter, because we're not using the data, we're using the summary. So stat, this is a proportion stats, 2 sample with summary. And now we need those counts. Oh, I should have written them down here. It was 52 out of 210. So 52 out of 210. That was for the hydroxychloroquine. And then it was, what was it? 18 deaths for the no hydroxychloroquine. 18 out of 158. And then we think that the first one is bigger, right? We think the death proportion is bigger for P1 than P2. I see that. Put in our counts. We need counts here. So we had to multiply the percentages that the study gave us by the sample sizes. Every study will always give its sample size because the value of the study is increased with increased sample size, the power of the test. It's more powerful if you have more samples. So they will always say the sample size. They won't always give you the counts though. Sometimes you have to figure those out. Okay, let's compute. And kind of as expected, right? That was a much higher death rate. So kind of as expected, pretty high Z statistic, 3.23, and a really low p-value. Z was equal to 3.23. P-value is 0.0006. So what should we decide? What should be our decision? And you can maybe just do a yes or type in reject if you think we should reject, or a no or do not reject. All right, Brittany says reject. Daniel says reject. They are correct, right, Nick? Yep, you got it. You should definitely reject here because you have a low p-value. Basically, what you're saying is there's no way for them to be, not no way, it's only 6 out of 10,000 times will they be that different at the sample level if the proportions are really the same. That's super, super unlikely. So we would reject the null hypothesis. And then this is where it gets a little tedious. We got to write this all out. There is enough evidence at the 5, I don't know if we did this for the first one. We should really state the level of significance, the 5% level of significance, to say that the death rate for those who were treated with hydroxychloroquine is higher than those who were not treated with it. Okay? And this is like real stuff here, right? Not only is this saying like, oh, the medicine doesn't work, this is saying like you could make things worse. It is interesting to note that if we go back to the study, where did my study go? It's over here, that the ventilation rates seem to be lower for those who had the hydroxychloroquine and the azithromycin. They needed less ventilators. So maybe what this study says is, hey, once you're really sick, it's going to make things worse. Don't give it to them. That's what we studied. But maybe it could help them early. If you have some symptoms, you're early and you've got this cough, whatever, maybe you do it then, and then if things get bad, then you stop. And you stop, because it seems to be that the combination, we didn't do this test, but it seems to be at the surface level that the number needing ventilation will be helped. So this is my point. This is the whole point of the class, is so you can do stuff like this that have real life consequences. This is real thing, like this is real stats. They just published this study April 21st, 2020, and they did a little more advanced analysis than we did, but pretty similar. So this is why, like, it sucks that we're not working on this together. I want to make sure you understand this, because this is the whole point of this whole semester, is what we're doing right now. Oh, sorry. Got a little excited there. Okay, that's it for today. Any last questions before we sign off? All right. When is the final test? Yeah, no problem. Let me pull the schedule up again, Nick. Well, I had it in the syllabus. So we've got this week, we're working on new stuff. And then next week, we're still going to work on more new stuff in chapters 12 and 13, which seems like a lot, but it's 3 sections, 2 from chapter 12 and 1 from chapter 13. And then the last week, we're going to meet on Monday to review the last unit. And then Tuesday morning, that's the 12th, I'll release the exam, and it'll be due kind of at the end of class on Wednesday. So it'll be due Wednesday at 2 p.m. That's when it'll be due. So that'll be Tuesday. If you want to maybe put like if you're like me and you can't remember everything, like put it in your phone. Tuesday at 8 a.m. is when that last exam will be released. And then it'll be due Wednesday at 2 p.m. Yep. All right, thanks everybody. I remembered to record today, which is not relevant to you because you were here, but for everybody else, I will post this. Yeah, I think that's it. I'll see you Wednesday. We'll do the rest of these examples and then you can ask any other questions that you have from the practice. Not a problem, Nick. See you, everybody.